Welcome, everybody. My name is Max Rome. I am the Stormwater Program Manager for the Charles River Watershed Association. And I'm so excited to be learning about mussels this morning. So the Charles River Watershed Association, we are a nonprofit that really focuses on the cleanup of the Charles River and understanding what can be done kind of at a watershed scale to, restore this river to ecological health and to achieve a swimmable and fishable river. And mussels are a huge topic of interest for us at CRWA. We always get a lot of questions about mussels from folks who are out on the river. There's a lot of places when we go out and we do our trash cleanups on the river where you can see kind of mounds and middens of Elliptio, and maybe they're telling us that there is a muskrat or maybe even an otter who likes to hunt mussels and likes to eat them on the banks of the river. And I think mussels are really, to me, a really mysterious creature, and one of the big mysteries that we can think about with mussels is how is it that these creatures manage to live in a river that's always flowing out to the sea, if they can't really move. And mussels have a life stage where they, are mobile and they attach themselves to fish as larvae and they make their way upstream. And that really helps us understand why thinking about mussels is so important to thinking about the health of the river. When we create dams and obstacles to the movement of those fish, that really restricts the ability of the mussels themselves to kind of move through the river system. And then just kind of one thing I want to say quickly is that, I think we're in a really important moment right now where a lot of people are thinking really hard about biodiversity. And freshwater mussels are an incredible group of organisms to think about in terms of biodiversity. Globally, there are about 900 freshwater mussels. 300 of them are found in the United States. And of those 300, more than 200 are, endangered or species of critical concern. So, thinking about mussels is a wonderful way to think about the ecological health of our rivers, and focusing on mussels is a wonderful way to focus on restoration and water quality. So we are really privileged and excited to welcome Marea Gabriel today. Marea is the Freshwater Manager for the Nature Conservancy in Massachusetts. She works with partners and communities to develop and implement projects that enhance river connectivity, natural flow, protect, restore, and reconnect floodplains, wetlands, and riparian corridors for both biodiversity and climate resilience. And before getting back involved with the Nature Conservancy, Marea spent 20 years as an aquatic biologist. A big focus was on freshwater mussels, but also vernal pool conservation. Marea is scuba certified and has literally surveyed hundreds of rivers, streams, and lakes in New England. So with that, I will just say thank you so much, Marea, and I will mute myself and turn it over to you.
Great. Thank you so much, Max. And thanks so much for having me today. I'm really excited to be here, and I'm excited that there are many people interested in freshwater mussels. So I'm here to share the wonders of these amazing animals. As Max noted, I have been an aquatic biologist for the first 20 years of my career. And a good amount of that time was actually spent underwater snorkeling and diving thousands of different river and lake sites for freshwater mussels. The last 12 years, I've worked with the Nature Conservancy. I'll use the acronym TNC going forward, but as a freshwater manager. And my work now focuses on conservation and restoration of freshwater ecosystems for both nature and people. So I've kind of structured my talk today in two parts. The first part will be focused on freshwater mussels. And then the second part, I will focus on some of the conservation and restoration work that I do with TNC. It not just protects mussels, but at a larger, more holistic level, it provides multi-benefits for people and nature. And one such strategy that we use is reconnecting rivers via barrier removal. So we'll get into the first part. And you all may know the Charles River far better than I do, but here's the Charles River watershed. I'm just going to give some summary facts that I'm sure many of you know. It covers 310 square miles, over 35 towns in relatively highly developed areas, and supports over 1 million people. The landscape drains via rainfall, snowmelt, runoff to the common water body, the main stem of the Charles River. Development, roads, impervious surfaces, and dams fragment and degrade ecosystem function here for nature and people. And there are, and I'm sure you know this, 19 dams on the main stem of the Charles River and another 100 plus or so in the bigger watershed. Many of these are still, many of these are not important. They're not serving their original purpose, but some are still important. And again, even though the landscape, the watershed has some degradation, it still is rich in biodiversity, as as Max just noted, many of you see the mussels as you're out on the river. So the waterways and the natural cover here support many common and rare species, fish, mussels, wildlife, plants, invertebrates, and others. And again, it's a very important recreational area for the community and beyond. So Max touched on this, the status of freshwater mussels. They're among the most imperiled animal groups in North America. We reach the greatest diversity of freshwater mussels in North America with about 300 native species in the United States. 35 of these are believed extinct, with another 70% listed as rare, endangered, threatened, or special concern. And populations have been in decline since the 1800s due to many factors. I'll just highlight, excuse me, some of the major issues. Early on, the button industry plagued mussels. The inner lining of the shell is called the nacre, or mother of pearl. It used to be used to make buttons until they started using plastic. So that those harvests really took a toll on mussels. Also, pearl cultivation. Back in the 1800s, when people discovered they could find pearls in freshwater mussels, they harvested them for those purposes. However, I would say in the 20 years that I've been working with mussels, I only saw one kind of partial pearl in a freshwater mussel. So they, again, harvested them, decimated local populations, and barely found any pearls. Also, cultivation in Asia was another impact to mussels. They discovered that they could take a piece of a mussel shell, place it in an oyster, and that irritant would cause the oyster to start to secrete nacre and create pearls. And then the big one that we all know about is habitat degradation and loss. And this is from dams, water pollution, excessive water withdrawals, sedimentation, channelization, dredging, and non-native species. In this picture down here on the right, this is a native mussel colonized with numerous zebra mussels. And I'm sure if you're out on the Charles, you also see the Asian clam. So mussels in Massachusetts, we have 12 species in total in Massachusetts. 6 of these are listed as rare. The red, this column here on the right, the red indicates the state listed at species. So we've got 6 of those. Actually, one of them is even federally listed. This is the dwarf wedge mussel. In the Charles River watershed, there are 6 species. 2 of them are state listed, the eastern pond mussel here and the creeper. And also the triangle floater, this was state listed as special concern. It was delisted actually when I was working at the state probably 12 years ago or so, or maybe even a little longer. It's still uncommon and it's still of concern. And then I will say, though, that the Charles River watershed is undersurveyed for mussels. Most of the records for mussels in the Charles come from a survey effort that took place, I believe, in the early 2000s up at the Charles River Natural Valley storage area. There were a few surveys later, but still, it's undersurveyed. And I will say that this triangle floater here, this species, I have seen some of the biggest specimens come from the Charles River. And big is great. It means they have lived a long life. But if you're only finding large animals, you start to get a little concerned that there's potential issues with recruitment and reproduction. However, again, the river's undersurveyed, so I'm not making that link. It's just information to share. And then freshwater mussels. I think this is a beautiful picture. I did not take it. My colleague Ethan Netto took this, but they are basically sedentary filter feeders living in the bottoms of rivers and lakes. This shows two different species here. This is the triangle floater. This species is known from the Charles. This is the brook floater, a state endangered species, and we have no records of this in the Charles River watershed, historic or current. What's great about these pictures is it so clearly shows the siphon. So this is an in-current opening siphon. It has these what are called papillae. These are basically sensory, a kind of a coarse filter. The animals filter the water in through these into their shell, which is burrowed here below the substrate, and then out through this external siphon. Okay, please excuse my kind of lack of artistic skills, but this is a sketch that I've drawn to kind of highlight the major parts of the anatomy of the freshwater mussel. So mussels are bivalves. There are two shells. Right now we're looking at the right valve and we're looking inside the right valve. This is the muscular foot that the mussel does use to move. Even though they are sedentary, they do move, and they use this foot to kind of dig and burrow into the substrate. This is the mantle that I mentioned earlier that lines the inner part of the shell and secretes the nacre, the mother of pearl. And here is the in-current opening. So the water moves in through the in-current opening, passes over the gills. As it passes over the gills, the mussels pull critical dissolved oxygen from the water. They also pull food sources from the water, and then they expel the water through their excurrent opening. And I didn't put this on this sketch, but the mouth part, so the food enters the mouth as part of this process, and in the mouth the mussels sort the food, and non-edible material is then moved out via the mantle and then excreted out another opening here. Okay, this is the really exciting part. Max alluded to this a little bit earlier, the mussel life cycle. This is fascinating to me, and it always has been. So during the breeding season, the female mussel lays eggs in her gills. During that same time, the male mussel expels sperm into the water column, and the female then needs to internally fertilize her eggs. So she needs to siphon that sperm in and internally fertilize her eggs. Then she will brood her eggs, and most species in Massachusetts will brood them in their gills over the winter. And then they have to release those glaucidia, or their larvae, to attach to the fins or gills of host fish. So this is releasing the glaucidia. This is what they look like. This is a zoomed in image of a glaucidia. I think it's pretty cute. And if you remember Pac-Man, it looks like Pac-Man from back in the day. And then they, again, need to attach to the gills or fins of host fish. And then once they've attached, when, maybe several weeks pass, when the young mussels are developmentally ready, they drop from their fish hosts and burrow into the substrate for several years. So they'll remain there until they're developmentally ready as adults to emerge. Again, this is really why it's important that mussels are close together, because this can be, as you can imagine, if they were separated by big distances, that reproduction piece is very challenged. And they've also come up with some quite amazing adaptations to attract fish host. This here is not a minnow. This is kind of an extension of the mantle of the mussel. It looks like a minnow. It mimics it to attract fish host. And one species in Massachusetts does have this tactic. Other species, some have like mucus strands that they float up into the water column, and as the fish move through, it's kind of like a spider web. They don't get entangled to the point where they're harmed at all, but they get a little entangled, and the glaucidia attached to the fish. Others simply just release them into the water column so that fish more haphazardly come in contact with them. And then some species have what's called a conglutinate. They release this small structure that has glaucidia inside it. It sinks to the bottom, it looks like a prey item, so fish try to eat it and they get infected. And again, another big table, but if we just look at this column here to the right, this is the number of known fish hosts for each species in Massachusetts. I haven't updated this. This could be a little bit, there may be some additions to this, but I think this is pretty much accurate. So what's really interesting in here, you know, sometimes you hear fish hosts, you think each mussel might have one specific host. They don't. They have multiple hosts. The tidewater mucket, this species is not known from the Charles, but it has just 3 known hosts compared to the creeper, which is known from the Charles, that has 21 known hosts, which is a little interesting to me in the fact that this species is less common, and even though it has that many hosts. And then the elliptio, which I'm sure you've all seen, probably many shells on the banks of the Charles. This is one of our most common species, and it can tolerate more degraded conditions, and it's got 18 known hosts. Okay, as I mentioned, mussels are essentially sedentary, but I love this picture. As I said, they rely on host fish for dispersal, and they do, but they actually can move. This photo was taken in a pond in southeastern Massachusetts after a hurricane. So those are trails, those are mussels, those little black specks, and those are their trails, and they're moving. So again, this is kind of a soft substrate, nice sand, but what I'm imagining happened here is all the wave action from this hurricane, the mussels probably became dislodged and disoriented. So they're probably trying to reorient themselves, moving to find a suitable place. And then just a very high level summary of mussel habitat. So they do require good water quality, some higher water quality than others. As I mentioned, the elliptio can handle more degraded conditions. However, many of our rare species require certain levels of dissolved oxygen, so water quality is critical. Adequate water quantity, again, very important if you're a freshwater mussel. Natural hydrology and flow, critically important as well. And as we mentioned, the presence of particular host fish. And stable substrates, river bottoms, that are free of heavy silt and sediment loads. This picture here shows a mussel nicely tucked in, stable bottom, very secure. What's great about this, it shows really what I kind of think of as perfect mussel habitat. It's got nice fine sand. It allows that mussel with its fleshy foot to burrow in easily, but it also is embedded with rocks and small cobbles, and that really stabilizes the substrate. And that's very important for mussels. When substrates become covered in silt and sediments, it's unstable. It's not a healthy environment for mussels. The other thing that this shows is that the water is clear. It's free of suspended solids, which is also important for mussels. And of course, connected rivers and land. These are vitally important. Free-flowing rivers regulate water temperatures, sediment transport, fish migration, and mussel dispersal. Adjacent vegetated riparian buffers, floodplains, and uplands filter and limit runoff, pollution, and sediment from entering waterways. And barriers like dams, I have these, yes, dams, culverts, and road crossings can fragment aquatic connectivity, restrict fish, mussel, and other species from moving to needed habitats, and can lead to flooding. And then mussels provide vital ecological services. And I've alluded to many of these already, but I'll just give you a summary. They're filter feeders, as we know. One mussel can filter 15 to 20 gallons a day. They clean our waterways and our public water supplies when they're filtering and consuming plankton, algae, bacteria, detritus, and contaminants. They're an important part of the food web. They're considered ecosystem engineers because they modify the aquatic habitat, making it more suitable for themselves and other organisms. This filtering service that they provide not only cleans water, but captures organic matter from the water. The mussels use it, and then they excrete the waste. And the nutrients are immediately available for plants. And the remaining organic matter that's deposited can be consumed by other invertebrates and fish. And the shells provide living spaces for insects and plants, and empty shells actually are used as nesting sites for small fish like darters, which in turn are host fish for mussels. There are obviously water quality indicators. Healthy populations are generally associated with healthy aquatic systems that are important for both nature and people. Declining populations can indicate poor water quality and degraded habitats. They're important food sources: otters, raccoons, muskrats, herons, egrets, and fish. And again, we've talked about rich biodiversity. So the greatest diversity is in North America, east of the Mississippi, compared to, there's only about 12 species in Europe and less than 20 in some other countries. So loss of any species, even some of our more common species, have consequences on aquatic ecosystem function. So you've heard me say that the Elliptio is more common. It can tolerate more degraded habitats, but that filtering capacity alone is vital to cleaning water. And then the cultural value. They are been important for indigenous tribes as food, shells for ornamentation, tools, trade commodity. When you look back at old villages and encampments, shell middens have been found to extend for miles. And now back to threats to mussel habitat. I've already talked about some of these, touched on them, but loss of vegetated riparian buffers, along with increased development and impervious surfaces, can lead to excessive runoff, pollution, especially phosphorus and nitrogen, and sedimentation. And this is only worsened by the heavy precipitation and intense storm events that we've experienced recently. Sediment, as I mentioned earlier, can just obliterate suitable substrate for mussels and can bury and suffocate mussels, while at the same time degrading water quality with suspended sediment, which interferes with mussel filter feeding and reproduction, with potential loss of less tolerant species. Water withdrawal and low flows in drought. So excessive water withdrawal. This happens to be a pond, and on the left here, a pond in southeastern Massachusetts. The dark specks that you can't see likely are dead mussels scattered throughout here. These sandy near shore areas, both in lakes and rivers, are believed to be important nursery habitat for juvenile mussels. They remain here for several years before emerging as adults. So water level fluctuations and rapid and prolonged dewatering for water supply, for flood control, or maintenance activities of dams can strand mussels, leading to massive die-offs of adults and juveniles. This is, I don't know if you can see this that well, but these are all dead or dying mussels and fish kills. So it leads to, not only mussel die-offs, but fish kills as well. And this is really important in this nursery habitat because this can lead to a loss of complete age classes here in a population. And additionally, low water and droughts prevent species from moving upstream. You see here this dam during drought. This is right here. I think it's right here in Metro West area. And also these kinds of conditions can lead to increased water temperatures. Warmer water holds less dissolved oxygen, which is vital for life in fresh water. So it also, leading to low dissolved oxygen. And again, fish and mussel die-offs, algal blooms, including toxic blue-green algae with impacts to people, recreation, and pets. And then barriers. We already touched on this as well, but barriers from dams, undersized culverts, and bridge crossings. This can limit host fish passage, reduce mussel dispersal, limit upstream colonization, which is very important, not just for mussels, but for fish and other aquatic species. As we experience warmer temperatures, even warm water species are going to need to move further upriver to cooler temperatures as refugia with climate change. As I mentioned, I've spent a lot of time underwater snorkeling and diving, and I really kind of had that fisheye or mussel eye view, if you will, of the impacts of barriers and dams to river connectivity. And the differences between naturally flowing systems and those with barriers were striking. I didn't even have to, you're just underwater and the differences just appear. Slowed flows and impounded flows come with the silt and sediment covered bottoms, stagnant and turbid warmer water with low dissolved oxygen, excessive nutrients with plants, And with this degraded water quality and physical habitat, I would see a plummet in species diversity. A plummet, I mostly was zeroed in on mussels, but an absolute drop in species diversity, changing to more generalist species and those more tolerant of degraded conditions. So not only can these barriers challenge fish and animals from moving between different habitats to fulfill their survival needs, but aquatic species populations can become physically and even genetically separated, with long-term consequences leading to decline and loss of species. Locally, regionally, and in the case of diadromous fish across the Atlantic coast. And barriers can restrict flow, leading to more flooding. Oops, there's a little pointing to the dam, missed that. Okay, so not all barriers can and should be removed, however, but improvements to them are vital, including fish passage. This picture here shows there's a dam here. This is a project I'm working on in southeastern Mass. There's also a dam up here, and here's a fishway that's been built to get the herring around these dams and further upstream. Expansive bridges. These are really important. This bridge expands beyond the channel, natural channel width. So this is critical, allowing the river to flow. It doesn't crossings often function as constrictions, as you can imagine. So when they're too narrow, they're backing up the flow, and that leads to flooding. And also culverts. Right-sized culverts are critically important. This is another good example. Again, it spans the width of the natural channel. It's embedded into the substrate, into the river bottom. The bottom of the culvert is filled with natural materials. And it is important this is very important, not just for fish dispersal, but even wildlife. Wildlife use these culverts to move. They follow river corridors. They're not inhibited from moving through here, and this prevents them from going over the road and mortality. And then sedimentation and invasive plants. So this actually is another project I'm working on in southeastern Massachusetts. Sediment combined with low flows and warmer water temperatures can lead to increased aquatic and invasive vegetation, and that's exactly what's happening in the case here. Natural hydrology has been disrupted, sediment transport has been altered, and what's happening is the sediment is building up in the stream. Invasives are establishing on this, and it's preventing movement and dispersal and leading to flood impacts. This also obviously can lead to algal blooms, and the aquatic vegetation further reduces dissolved oxygen levels, increasing potential toxicity, and again, fish and mussel die-offs. And I think I mentioned this already, warm water holds less dissolved oxygen. So number one, we have less dissolved oxygen, but when you have all these aquatic plants, and in this case, this photo here shows you milfoil in the same river, an aquatic invasive plant, when they consume oxygen overnight. So this also enhances depletion of dissolved oxygen. Sometimes the milfoil is so thick in this system, it's very hard. It restricts fish and mussel passage and degrades or limits a suitable substrate for mussels. The Asian clam, which we touched on earlier, these animals are capable of rapid reproduction. Dense populations with the high filtering capacity can alter aquatic ecosystem processes, especially when they excrete high levels of nitrogen, stimulating algal and plant growth. And decomposition after massive clam die-offs can also degrade water quality. More research really is needed to understand the implications for freshwater mussels and whether dense populations of the Asian clam can displace mussels, and also if they compete for their food resources. And then all of this, degradation can lead to the increase in algal blooms and closing of recreational areas. And then, of course, all of this is compounded by climate change. Freshwater ecosystems are already feeling the effects of accelerating climate change, and they'll suffer disproportionately, losing more biodiversity than any other system and lead to more public safety hazards. So mussel conservation. I'm just going to go over quickly just some of the top issues. We've touched on all of them really already. Restore river connectivity, obviously, so fish hosts can move and expand their range, help mussels colonize new habitat. Oh, evaluating the impact of water withdrawals. I didn't talk a lot about water withdrawals, but clearly that's a very important issue for mussels. Hydrological modeling could be used to determine available habitat at different flows. And then even reviewing municipal or commercial requests for increased water withdrawals is important. Riparian restoration and bank stabilization. We talked about this earlier. This is especially important in areas with poor land use practices, where there are inadequate forest or vegetated buffers, where there's agriculture, golf courses, grass lawns, etc. Land protection, that one goes without saying. Acquiring land along rivers protects these riparian areas. And the adjacent uplands that are needed to ensure clean water. And restricting salt use. I won't go into this one too much, but obviously salt can change the water chemistry, and that many mussels are very sensitive to that. So you can work with your DOT and DPW to identify and alert them to important mussel sites. If possible, limiting or reducing salt, sand, and other de-icers at road crossings and bridges, preventing the dumping of plowed snow into the river or on the banks, and also consider monitoring salt levels in the river. And restricting livestock access. This may seem unusual in the eastern part of the state, but in other areas of the state, in the western part of the state, this is a serious issue. Cows and other livestock are using rivers as water sources, and obviously they're trampling and degrading the banks. There's waste in the water. This all degrades water quality significantly, and there have been some pretty dramatic mussel die-offs associated with it. Survey and monitoring. So over the past 30 years, we've really stepped that up. We've pretty much surveyed much of the state. There's still areas to be done. But long-term monitoring is also important, and we need to initiate more of that. And now I'm going to get into part 2 of the talk. And so this is where I'm going to talk a little bit about my work, restoration and conservation work with the Nature Conservancy. So freshwater ecosystems, rivers, lakes, and wetlands are in peril around the world. They only make up less than 1% of the Earth's surface, but they play an outsized role in sustaining environmental and economic systems that both nature and people rely on. Only 1/3 of the world's largest rivers remain free-flowing. Freshwater plants and animals have declined 83% since 1970, more than any other biome. Half of all the people on Earth now live in water-stressed areas. So more frequent and intense storms and excessive heat will exacerbate these issues. And freshwater systems will continue to deteriorate at alarming rates, and impacts such as flooding, biodiversity, water scarcity will worsen. So TNC has a freshwater imperative, a global freshwater. Clearly, in summary, conserving freshwater ecosystems is an imperative that connects us all. Rivers, lakes, and wetlands sustain communities, drive economies, underpin entire food systems, shape landscapes and weather patterns, and nourish an intricate web of biodiversity. They're essential for all life on Earth, as we know. And look at that twice, so we'll skip that. So to address this freshwater imperative in Massachusetts, we are committed to 2030 outcomes. And this is not just our own work, but it's also supporting others and our partners. And so, sorry, little glitch. Okay, and these are to protect, restore, and reconnect rivers and streams. And we have a goal by 2030 of 1,000 miles. To protect, restore, and reconnect floodplain and riparian areas, 25,000 acres. And to protect and restore watershed lands and headwaters, 150,000 acres. And again, emphasizing not on our own, but working with our partners and other interested parties. So I'm just going to focus, much of my work right now is focusing on reconnecting rivers and streams strategy. So I'm going to focus on that today. As noted, again, it's 1,000 miles of rivers protected, restored, and reconnected. And I'm adding that we also want to ensure that 2 million people benefit from healthy freshwater systems. And so one way we do this is by modifying or removing obsolete dams, restoring natural flows, and reconnecting river systems to their floodplains. And I want to put my mussel hat on for a second and add the caveat that any restoration actions need to be done with an awareness of freshwater mussels and an ability to protect them. So dams in Massachusetts, this is quite a picture. We have over 3,000 many are old dams in Massachusetts, many are in disrepair, and only about 10% of them still provide energy, drinking water, or flood control. Over 1,000 have been designated by the state as high or significant hazards. So if they were to fail, they are public safety hazards for downstream communities. And we can only imagine that these numbers will grow with increased precipitation, storms, and flooding. And I just want to share one example. This is a dam along the Mill River in southeastern Massachusetts. And this is one of 4 dams that TNC, along with Mass DER, the federal agencies, dam owners, and other local partners, one of 4 dams that we either removed or augmented in the system. And so in 2005, the hurricane almost threatened the failure of this dam and caused the evacuation of downtown Taunton at a cost of $1.5 million. That was the impetus for the formation of this Mill River Restoration Partnership, as I mentioned. Ultimately, this is the same dam. It's been removed. You can see the impoundment is gone. It is restored with natural vegetation. Ultimately, this project led to the removal of 3 dams on this river from 2012 to 2018 and a fish ladder at the 4th. The cost just to remove one dam was $500,000 versus the estimated $1.9 million to repair and maintain that dam over time. And I think it was in 2018, right, when the dam was taken out, herring were observed moving up the Mill River for the first time in 200 years. And by 2021, 20 or 30,000 herring were estimated migrating up the Mill River. So I'm just going to summarize. Obviously, there's a lot of detail that goes along with removal of dams, but the benefits, there are many. They removed, obviously, barriers to upstream and downstream passage and habitats for fish, mussel, and wildlife. They enable migratory fish like herring to reach upstream spawning habitats. They help with natural hydrology. They provide cleaner water. They improve public safety, reducing risk of flood and drought and dam failure. Improved economies, avoided costs of business closures and emergency response. Financial benefits, eliminating dam owner long-term repair and maintenance costs, as well as liability. That Mill River project, DER estimated that it's 60, on average, it's 60% less expensive to remove a dam than it is to repair and maintain it over a long period of time. There's also, believe it or not, studies that show dam removal do increase property value due to reduced flood risk and eliminating the unpleasant stagnant ponds. They do provide new recreational opportunities. And again, it's an opportunity to help restore the relationship, use, and access of indigenous tribes to the river. Also, I didn't add on here, but as many of you have heard, it's an kind of unprecedented time as far as funding available to both federal, state funding to work for barrier removal and to reduce climate risk. And I'm getting to the end. So in closing, I just want to say, obviously, I covered a lot in a short period of time, but freshwater conservation is complex. And reconnecting rivers and streams is just one of the strategies that we're using towards addressing not only TNC's freshwater imperative, but at a higher level, the dual crisis of biodiversity loss and climate change. But there is good news. The good news is that degraded freshwater ecosystems can recover quickly. I shared some examples. The example on the Mill River, the flood risk was removed and the herring returned immediately. Just to share, a little more positive news, in the last decade, 346 dams have been removed in the Northeast, reconnecting 3,500 miles, and over 2,100 dams, it's probably more than this now, in the US have been removed since 1912. And obviously, we know there's still water quality issues in the Charles, but there's been huge improvements in the Charles River from decades ago. And with these actions, ecological integrity can be restored and climate risks reduced with benefits to nature and people. And if anybody's interested, there's a wonderful brochure that Mass Wildlife has put out, and it opens up and you can see every mussel and learn about them. I think that's available at their office. And that concludes my talk. I'll stop sharing. Does that make sense to stop?
Yeah, perfect. Thank you so much, Maria. That was a wonderful, wonderful talk. Well, we've got time for a couple questions, so folks can raise their hands or just go ahead and come off mute. You can, if you want to drop a question in the chat, we will read it as well. But yeah, one thing I'll just kind of start with is I know we have a lot of interest in understanding what mussels are in the Charles and what mussels are missing or what habitat is unavailable to them. What would be a good way for us to kind of have an updated mussel survey for the Charles?
Yeah, that's such a great question and so needed. And again, I can't speak for the mussel biologist, but when I was in that role, we did train volunteers to get out there and help us survey. And it's very simple. I had a picture of what we used to use, mostly when we're with volunteers, is these plexiglass bottom, those big, I don't know how many gallon buckets they are, but you literally walk along the river with your head in the bucket. You look kind of funny, but you can see the bottom. So we trained volunteers on mussel identification. You don't want, in a dense bed, you don't want too many people walking around and crushing mussels, but that is one way. And I can't speak for the state biologist, but I know that Jason, he did get out there and do a couple surveys to try to update some of those rare species records. Unfortunately, he didn't have success. I'm sure it wasn't an extensive survey. So communicating with, you can reach out to me and I can reach out to him and just say, if there's interest, certainly I know it's probably on his list to do. If you wanted to raise some funding to do it, there are mussel biologists who do these surveys, and I used to contract with them directly a lot, and they're very, very good, and they could do a very good and thorough survey for you. And it's basically about getting, presence, absence of species. They don't do any intensive they could do quantifiable surveys, but they do kind of a presence, absence, and a general assessment of density.
Thank you so much, Maria. We will follow up for sure. Carl, want to kick us off here?
Sure. My name is Carl Zimba. I'm the president of the Charles River Alliance of Boaters, and we've been looking at this issue for quite some time now, exploring different things. Chiefly, our concern, well, one, I think these mussels are essentially a sentinel species. And as the river got more polluted, they died off. It didn't help changing from a saltwater environment to a freshwater environment when the dam was built. But we believe that now the water quality has returned, we should be restoring the biota, which includes reintroducing these to the environment. So one of the questions we have had is, if we wanted to introduce mussels to the environment, where do we get them and how do we do it?
That's
And
a
I've
good
run
idea.
into a number of roadblocks on that, which has really been fairly discouraging.
Mm. Yes, and it's complex, and they do it. There is propagation mostly in other parts of the country. They do have there is a fish hatchery that they're using to experiment with growing mussels in Massachusetts, or there was, but propagation is used for our rarest species. You know, when you're concerned that a population is going to wink out, they will grow mussels in either fish hatcheries or some other kind of, you know, lab setting, with the intent of restoring you know, either a new location, or if, like you said, if it's cleaned up, restoring them in that same location. It's complex though, because you know, you definitely have to talk with the mussel biologist. Maybe you have already at the state. It's complex because you need to really have, first of all, that survey that you want is really good. You need to have a baseline. You have to understand what's there. And then you go from there. You can't, you know, you need to know what species are suitable for the habitat, how are they tolerating it? And you certainly don't want to put mussels into a habitat that is somewhat degraded and there's no chance of success. So even understanding the habitat conditions is really important, and the water quality. So I would start with that survey that you're talking, you know, that you have interest in, and then communicating with the state biologist on the potential for this. You know, again, the state is at capacity too. This is not something that they do, but he would probably be able to direct you to, if it's not him, the right people to talk to. And I certainly can reach out to him too. I'm not doing this anymore. It's been 12 years since I was really focused on this. This is more falls into the science category of it all, but it is complex. It's not as simple as just putting the mussels into.
No, I think we all realize that, but we did, I mean, I have spoken and I have visited the project down in Philadelphia where they built a hatchery to populate the Schuylkill, repopulate Schuylkill.
Mm.
And they were quite encouraging, but apparently there are some fairly strict laws about sourcing these individuals to your watershed.
Mm-hmm.
Okay, they have to be locally grown. They can't be transferred between watersheds. They certainly can't be transferred between states.
Right. No, they can't. And it's important for introduction of any kind of like disease or parasite or anything that can be coming from another source. So it has to be closely monitored and permitted. So again, I don't know the specifics of that since I'm not focused on this anymore, but happy to reach out and get more information for you on this. And we can share my email, and we can communicate some offline on that if it's helpful.
Yeah, that would be very helpful. Thank you.
Yeah.
Yeah, thanks, Carl. Thanks, Maria. Feel free, folks. So we've got till noon, so we've got another 5 minutes, but I'll keep asking questions if nobody else is gonna jump in. But you know, so in the Charles right now, you know, there are a number of dam removal projects that we're thinking about, and we're also kind of developing you know, a more comprehensive framework for the restoration of the river and understanding how to prioritize dams, you know, which dams to kind of prioritize. I'm just wondering if you could share, you know, from a mussel perspective, what are some of the factors that you would kind of put into prioritizing,
Yeah,
or
absolutely.
looking at pre and post, you know?
Yeah, right. So given that I was the mussel biologist who reviewed dam removal projects prior, and now I am the one requesting to do some dam removals, I'm actually doing that on a very, very important river that supports our federally endangered mussel. So you have to have a good understanding of mussel presence and distribution prior to any work. So as I mentioned earlier, like there's that caveat. Restoring river connectivity and removing barriers to movement and flow is vital. but you have to do it in a way that protects the animals. And so obviously the permitting process, as you know, going through dam removals is very rigorous and addresses many of the concerns that we would have with mussels, which is a lot of it is sediment moving downstream, displacing or actually directly harming and killing mussels during the process. So number one, you really do need to have that baseline understanding of what species are present, abundance, and then you need to come up with a plan, which you would obviously go through Natural Heritage and Endangered Species Program. You've got rare species. Not every, well, if you have rare species, which you do, depending on the dam, it may go through heritage review, and therefore they would guide you on the specifics that you would need as far as monitoring. And then there will be, in many cases, there will be follow-up monitoring once the dam is removed to ensure that to understand and ensure the outcomes have, enhance the mussels. And also during a dam removal, you likely need to work with a mussel biologist to move mussels out of harm's way. So both upstream and downstream of the dam, they'll need to be most likely removed and located to, place out of impact from the removal operations.
Thank
And
you,
again,
Maria.
most of that is there. It's a lot of that's
Yeah.
triggered by whether there's rare species present.
That's really interesting. All right. Anybody want to ask a last question? Otherwise, I'm going to ask one more question and then we'll wrap it up. This is another one that's a little bit out there, but CRWA is, very involved with, there's a large project happening in Alston that's going to, essentially involve reconstructing a portion of the riverbank that's right now kind of a stone granite abutment. And I'm wondering, are there any, from a mussel perspective, I mean, I know you have many other hats besides the mussel hat, but what are some considerations about bank reconstruction from the perspective of, promoting native mussels and maybe mitigating the presence of the Asian clam?
That's a good question. Mitigating Asian clam is not necessarily going to happen with the restoration actions, unfortunately. But as far as, banks are vital, as I alluded to earlier. Stable and secure banks and riparian vegetation is vital to healthy mussel habitat. You want to prevent erosion and sedimentation from getting into the waterways. You want to have the riparian vegetation there as well to filter and limit pollutants and sediment from entering the waterways. So all of that is, again, vitally important to healthy systems. Also, having a more natural channel, removing that hardened structure will, when the engineers are designing that, they will look at flow and velocity and make sure that they're trying to mimic the natural flow and velocity, which is also very important. You also, in some systems, you may want to, obviously I'm not an engineer, but they look at the channel and they're going to want to either add riffles. Riffles increase dissolved oxygen, very important for healthy aquatic systems. So there's a lot that can be done and that will be taken into consideration given the species, and not just the mussels, but the other species are there and the habitats that you want to create. Are you creating spawning habitat for anadromous fish? That's another consideration they're going to want to take in when they're designing that bank and channel restoration. I'm sorry, I can't answer the Asian clams.
No.
That may not, that's tough. I'm not, I'm not in the field a ton anymore, but increasing flow may help with Asian clam, because where you often see them is in these slower, more stagnant situations. So that may help with Asian clam.
Well, thank you so much, Maria. And we've got Maria's email in this chat. You can also reach out to CRWA directly to get in touch with Maria if you're watching this recording. Yeah, stay tuned. This was fascinating, and I think there's going to be a lot of kind of follow-up from this conversation that you're starting with us today. So
Great,
thank you
great.
so
Thank
much.
you so much. I enjoyed it. And please, anyone feel free to email me with any other questions or to follow up offline.